You're welcome to tedtalks.com. My name is Usoboziwe Joseph Bineb, and we are still looking at organic chemistry, and basically we have advanced and reached on looking at gaseous hydrocarbons. Gaseous hydrocarbons. Now, this somehow excludes some organic compounds that are so bulk and complex that will either be in solid form or what, but we're basically looking at gaseous hydrocarbons. And we want to establish what is the effect of burning them, and preferably burning them in excess oxygen. Now, let us consider that we have a hydrocarbon HCX, HY, which is a gas, which is gaseous, and it is possibly reacting with oxygen. And given the fact that we are looking at using excess oxygen, all of it should burn completely. Burn completely, liberate hydrogen gas and water. But this doesn't come out as water, it comes out as a gas. But after coming out as a gas, then we condense. Remember, it comes out as a gas, then when we condense, it is easy to condense water into liquid, but carbon dioxide still remains in the gaseous state. So look at this reaction after we have condensed and remained with the liquid water. That's why I come right away and call it a liquid. Now, looking at this gaseous equation or combustion of a hydrocarbon, we shall look at gaseous hydrocarbon. We shall first of all look at balancing it. Oftentimes we tell learners to write and balance this equation. We start by looking at X. We have X carbons. X carbons, but this side we simply have carbon. So in order to balance it quite well, we are about to put an X here. So that's why we go ahead and have X there. So the X's, the carbons, have now balanced by a virtue of multiplying the carbon dioxide by X. Now that takes us to hydrogen. Here we have Y hydrogen, but this side we have got two hydrogens. We've got two hydrogens. So to balance them off, remember they should balance. To balance them off, we think, remember there's no topic called balancing, but we simply find ways of how we can work out things to ensure that the atoms on the right hand side balance with the atoms on the left hand side. So what we can do, we are actually having 2H in two brackets. We can multiply it by Y over 4. Yes, so when we multiply by Y over 4, then we shall be very sure that we get 2Y over 4 hydrogen actually better do it like this. This is 2 hydrogens. This is times the Y over 4. So when we multiply by Y over 4, then we get 2Y over 4, then hydrogen. So that takes us to a half Y hydrogen. That's what we would be having. So, but this a half Y hydrogen remember this hydrogen here has a 2. So when you look at that 2 is what would cancel out with this a half, and then we come up with Y hydrogen. That's why we'll go ahead and have Y over 2 here. Y over 2. So that this a half which is here times this 2, then we'll come back to Y hydrogen. And for that reason we shall say we have been able to balance the hydrogen atoms. Okay, then we look at oxygen atoms. We look at oxygen atoms. On the right, we have 2x oxygens plus Y over 2 oxygens. And when we factor out oxygen and yes, we can factor out oxygen, we get oxygen into brackets 2x plus a half of Y. Get a half of Y. Now, but remember, on the left hand side, we have 2 oxygen atoms. That means if I can multiply this by 2, in other words, on the left hand side I'm having this. I'm having a bracket with the 2 oxygens. So if I can also increase this by 2, that means the ones inside I have to reduce them, so that I would really try to balance it. So that's why I should make sure that I have, if I have 2 here, then I will say this is x, 2x out of 2 plus a half y, but out of 2 also. So the whole of this, if I'm multiplying it by 2 oxygen atoms, then it will become equal to 2 oxygen atoms. It will become equal to 2 oxygen atoms. This is x plus y over 4 into brackets. So now I have this expression which is very much similar to the one which is here. Actually, the contents outside the brackets are the same like the contents outside the brackets here. So it is a matter of simply having this inside the bracket, then I'll consider to have balanced my equation. So that is how that equation of a gaseous hydrocarbon can be balanced on complete combustion. So that's how we really obtain it. So to be very smart, we can say this is carbon, their x, that value is not known, then y, and we are saying this is a gaseous hydrocarbon reacting with the excess oxygen gaseous state to obtain x carbon dioxide gas plus y over 2 water molecules. But like I said, this water molecule is obtained as a result of cooling. When you cool down, water is able to move from water vapor to form liquid vapor. But now remember, we said this oxygen is used in excess. Being used in excess means it will react and all the hydrocarbon is reacted. This is fully, completely reacted. Because it is limited, but because this is excess, then it is partly reacted. That means by the end of the reaction, we shall have part of oxygen reacted, part of the oxygen unreacted. So, the unreacted oxygen plus the carbon dioxide gas formed, because those are the two gases that are present after the reaction. The unreacted oxygen plus carbon dioxide formed is what we call residual. We call it residual gas volume. Call it residual gas volume. Call it residual gas volume. Now, that mixture is what we intend to separate into two separate layers. How do we therefore separate it? Remember, we had the hydrocarbon volume, which is very well known, and the volume of the excess oxygen, that is very well known. But because this is excess and this is limited amounts, the whole of this one reacts completely and part of this remains unreacted. Now, that part that remains unreacted plus the carbon dioxide formed make up the residual gas volume. Now, to separate these two gases, we come and pass through. We come and pass through concentrated sodium or potassium hydroxide solution. Now, when we come and pass through any of the two solutions, actually we can say concentrated alkalis. The concentrated alkalis is a base, and therefore this base reacts with the carbon dioxide, since this carbon dioxide is a gas, is an acidic gas. So acidic gas reacts with the alkalis to form a salt. Therefore, the residual gas volume reduces. So if the residual gas volume is known and it reduces by a given amount, then that remaining volume of a gas is supposed to be volume of unreacted oxygen gas. So can later obtain volume of unreacted oxygen gas by subtraction. By subtraction, because we shall be having the residual gas volume. When we pass in through potassium or sodium hydroxide solution, this volume reduces. So the one that has gone away is volume of carbon dioxide gas, and the one that remains as part of the residual gas volume is supposed to be volume of unreacted oxygen gas. So by subtraction, we shall be able to obtain volume of carbon dioxide gas formed and volume of unreacted oxygen. So later we use these two informations to go ahead and calculate volume of, the formula, the molecular formula of the hydrocarbon, which is in the gaseous state.